All right. At least two of my clocks say 12 o'clock. So it's 12 o'clock on Wednesday. It's time for the Iowa Learning Farms Conservation Webinar. I'm Matt Helmers with Iowa State University and really fortunate to help host many of these webinars and certainly excited to hear about the topic and from our speaker today. Megan Anderson is an extension field agronomist with Iowa State University Extension and Outreach, has a long history working on weeds. And so her talk is water hemp is killing us, but can cover crops save us? So with that, I'll turn it over to Megan. If you have questions, please type those in the chat box and we'll get those to Megan at the end of her talk. With that, the virtual floor is all yours.
All right. Thank you so much, Matt. Excited to be here today. 25 minutes isn't a ton of time to cover this topic, but I'm excited to cover what I can, and feel free to reach out to me afterward if you have further questions. But just to reiterate, my name is Megan Anderson. I'm an extension field agronomist for Iowa State, which means I'm not a researcher on campus, though I've done some research in the past. I am out in the field helping farmers and ag service providers implement tactics to improve management all across the board for lots of different things, including things like cover crops and weed management. And I am just one of 11 areas across the state where we've got field agronomists stationed to serve the people of Iowa. And so if you ever need assistance with anything agronomic, there's a whole bunch of us across the state available to help. So just a brief outline. So we're going to talk about how our water hemp problems continue to worsen every year, and how cover crops can effectively suppress weeds if they're managed for that purpose. And so at the end, we'll discuss sort of how we put these two together to hopefully get some successful weed suppression using cover crops in Iowa. And so we have a lot of issues with water hemp. So these are two pictures that I actually took just this year in the end of July and in early August in some soybeans and some corn in Iowa. It used to be that we had water hemp issues in soybean, difficulty controlling the water hemp in soybeans. We were able to clean it up in the corn year. And now we are at a place with weed management where the issues continue to worsen in both crops. In fact, are even harder to control in corn sometimes than in soybean with some of the growth regulators that we're using in beans. And water hemp poses a severe threat to crop yields. Water hemp emerging as late as V5, that's 5 trifoliate leaves on those soybean plants, can reduce yields as much as 10% if we've got a large population of the water hemp out there. And season-long competition in corn and soybean could be absolutely devastating to these crops as far as yield goes, on the order of somewhere from maybe 40 to up to potentially 75% yield loss. And that's just the consequences in season that single year, not discussing the consequences to the soil seed bank and future years of weed management and the ability to actually produce crops in our crop fields. And so I just went through a little math exercise to just sort of demonstrate what we see year over year. And so this is the hypothetical consequences of an individual survivor. So say one female plant survives in a crop field, perhaps in soybean, and produces 300,000 seed. That's a pretty big water hemp plant, but one survivor producing that versus 10 survivors producing 30,000, you can very quickly get to 300,000 seed. And say 6% of those seed are going to germinate the next year, half of which will potentially be female. And maybe each of those females we're going to get, or each of those plants we're going to get 99.9% control of. So a very small percent, 0.001% of those germinated plants are going to survive. And maybe each of those produces 50,000 seed. And so you can see over the span of 15 years, we've gone from adding 9,000 seed that are showing up as plants, and or 9,000, seed germinating, that are showing up as plants in the field, to by the 15th year, we're over 2 million seed that have germinated into plants in that whatever area we are talking about. It's pretty quickly able to get out of hand. And we're seeing this happen all over the place, not just in Iowa, across the Midwest. We're seeing herbicide resistance issues resulting in problems controlling water hemp, meaning we're dealing with more water hemp plants, and we're seeing that problem get worse every year. So in some cases, we've got up to 7-way herbicide resistance in water hemp, which is pretty devastating to our weed control options. This is just a nice table that shows the herbicide groups that most farmers are using in the Midwest to control water hemp and other weeds. And so you can see here we've got about 10 herbicide groups. And if we start looking through what's available to use against water hemp, of course, the group 1 herbicides are grass killers. So those are not going to be effective against water hemp in the first place. And so that leaves us with 9 options to control water hemp to varying degrees of success. Some of these herbicides are obviously better than others, but we can very quickly tick off 7 of those 9 herbicide groups as known resistance issues, with the 8th herbicide group, that group 10, Liberty glufosinate, as being likely resistant in some scenarios. And so this isn't just a hypothetical case of, oh, maybe someday we're going to have trouble controlling water hemp. This is real time happening in our crop fields and getting worse every year, with not a lot of sunny outlook on the horizon as far as some sort of broad solution that's going to solve all these problems in a really easy kind of way. And so I'm a big fan of Calvin and Hobbes. And so, as Calvin would say, nothing is ever easy, right? We've used herbicides for decades now, and they're a relatively easy solution to herbicide or to weed management issues, right? They're easy to implement. We can use them across broad acreage. We can put them on quickly and in a more timely manner than, say, doing cultivation on every acre. And with easy solutions come our weeds being able to overcome those easy solutions. So weed suppression with cover crops is not a new thing. It's, I think, I would like to think it's fairly settled science that we can suppress weeds with cover crops. And so here's just some nice images, one of corn and one of soybean, with a good stand of terminated cereal rye in it. And so, biomass is the key to physically suppressing weeds. There's a lot of dynamics that are happening in the soil, in the cover crops interaction with our germinating weeds. Cover crops are better at suppressing some weed species than others. But the real key to getting that longer weed suppression, is not necessarily allelopathy. It's not necessarily that it's taking up water, right? Removing water availability from weed seed or doing other things. It's that you have this physical mat of material there that's basically acting like it's kind of thickening the soil, right? So we've added a couple inches of rye residue, and that makes it harder for our small seeded plants to get sunlight, and harder for them to germinate and actually emerge through that. But like with everything, it's not 100%. And so I'm a parent of a couple young kids, and I hope others can appreciate this, that I always laugh when I get out the kids' diapers and it says up to 100% leak proof. And it's like, well, yeah, maybe it's 100% leak proof. So much like cover crops, maybe we could get up to 100% weed suppression, but the reality is not that. And so I think we have to realize the limitations of the biological system in which we're working with, that a cover crop alone is not likely to solve the problem. And so this was some nice work done out of Missouri, where they looked at a number of different cover crop species, and they looked at the weed suppression that they got from that each individual species against water hemp, and then compared it to the weed suppression that they got overall. And water hemp's a really good example of a species that we can suppress well, as long as we've got good residue present when that water hemp is emerging, which is unfortunately typically later in the season than a lot of other species. but we're likely to get better weed suppression with a species like water hemp than we are with something like giant ragweed or velvet leaf or sunflower that have very large seeds and are likely better able to emerge through that thick mat of residue. And so in none of the cases in this particular research and in most other research, we're not seeing 100% weed control, but 50, 60% weed control is feasible and would be a huge help to suppress water hemp and make sure that our herbicides that we're still relying on are seeing fewer weeds there later in the season, because the fewer weeds we can expose to these herbicides, the longer it's likely to take herbicide resistance and other issues to develop in our fields. And so I've used this graph countless times. This was some southern U.S. work done in 2013 looking at cover crop biomass by Palmer amaranth suppression. And I like it because Palmer amaranth is the South's version of water hemp, basically. It's more aggressive, but similar seed size, similar ability to produce seeds, similar herbicide resistance issues. And they were able to look over a very broad range of biomasses, right? Anything from basically no biomass, sub 3,000 pounds per acre, which would be a pretty small cover crop, all the way up to something that's producing maybe 10, 12,000 pounds per acre, which is just an absolutely enormous cereal rye cover crop. And so I did work in 2014, and my work in central Iowa that we terminated in the first or second week of May got biomass anywhere from maybe 500 pounds per acre all the way up to close to 4,000 pounds per acre. And so again, you can see that we're not getting 100% weed suppression. We're not in this 100% weed suppression realm, but we are getting some incremental help in controlling our weeds. Mirsky et al. In 2013, they said for consistent suppression of summer annual weeds, they were saying somewhere up in like the 7,500 to 8,000 pound per acre range. And then Nichols et al. Did a nice review in 2020, and they sort of said for a 75% reduction in weed biomass, not necessarily plants themselves, but weed biomass, they were seeing something like 4,400 pounds per acre, which is completely doable in Iowa. And again, that's for a 75% reduction, right? We can get by with less than that. And so this is just some work that I did as a part of my research when I was a grad student at Iowa State, and looked at the effect of a cereal rye cover crop on water hemp emergence patterns. And so we saw that with that mid-September planting, accumulating somewhere in the range of about 2,500 to 3,000 or 3,500 pounds per acre of biomass. That's about a 18 or 20 inch tall, nice mat of cover crop cereal rye. We moved the emergence time on water hemp later by about 2 weeks. Well, what does that mean for us as far as water hemp goes? That means we've got less biomass later in the season. Those plants are able to produce fewer seed. It gives us a wider window of opportunity to actually treat those weeds with a herbicide when they're small, right? So we're able to actually maybe get them when they're 2 to 3 inches tall instead of getting out there when they're 6 or 7 inches tall and missing some of them because of that. And it means that if they do survive that whole season, they're causing less yield loss for our crop, which I think is hugely important as well. And so putting the two of these together for a solution. So can cover crops save us, right? Are we likely to get this beautiful thick mat of cereal rye in this picture every year in Iowa that equally suppresses weeds across the field? And, we get no water hemp coming up? No, probably not. Maybe some years we can do that, but probably not. But cover crops sure can help. And this is just a nice little image depicting the many little hammers approach to weed management. So herbicides have traditionally been a big hammer, and they're a very effective way to control weeds until they aren't. And now we really need to think about preserving the utility of our chemicals, our herbicides, by bringing in other tactics to help those herbicides continue to be efficacious long into the future. And so cover crops they're not likely to replace herbicides in a traditional agronomic system in Iowa. But they absolutely can help displace some of the pressure that we have on our herbicides to work well. And so what does that mean? We have to have a good stand of well-established cover crop. So monoculture cover crop of something like a grass in Iowa is likely to be much better at suppressing water hemp than even other species or mixtures. And so cereal rye is sort of the gold standard so for high biomass accumulation. And so if we can mix cereal rye with other things, but just realizing that if our goal is weed suppression, that is not likely to help us. Our best bang for our buck is in getting a good stand of a monoculture that's going to overwinter and produce a lot of biomass. It may mean late planting of the crop. And so this is something that I think there's been a lot of really good work on in recent years, looking at can we plant soybeans early and terminate rye later? Can we move this around in different fashions to make sure that we aren't sacrificing, say, soybean crop yield in order to get this high biomass accumulation and actually make our cover crop do the weed suppression for us? So unfortunately, this is probably not going to work really well in corn due to the competitive issues that we have with cereal rye, some of the green bridge problems and other things. Perhaps in the future, we can find a way to make this work really well, maybe by allowing rye to grow in the interrow, but terminating rye over right where the corn is growing and using a herbicide in a band only in those areas. But right now, this has real potential to work in soybean because soybeans can be much more tolerant of the residue. We can plant them over a much wider window, and we can actually, in some cases, terminate at or shortly after planting and not incur any yield penalties as a result of that. It may be field specific where we want to use these kinds of practices, or even parts of fields, right? Field edges have traditionally been far more problematic for weed issues than other parts of the field. In my neck of the woods here in central Iowa, we have a lot of parts of fields that drown out and they just become weed havens. So are there ways that we can use cover crops to maybe soak up some of that early moisture that we get in those spots that have historically drowned out and help suppress weeds? So even if we can't establish a good crop there because there's so much moisture, maybe we can have something that was established there that at least helps reduce some of the weed issues that we see. That may be a little pie in the sky, but there perhaps are some ways to feasibly make this work in the future, especially as we look toward using things like drones and other sub-field level management capabilities with small tools and technology that can really help us. So in order to get our rye established well, we probably need to both seed it early and probably terminate it later than in some cases we would like to. And so this, I think I saw Bill Curran on here, so I totally swiped this slide from Bill, and I appreciate that he put this together. But this was just a nice little graphic summary of some research that was done in 2009, where they looked at numerous planting dates as well as numerous termination dates. And so what they found sort of out east, but I think would translate well to Iowa, was that 30 days in the fall was roughly equal to about 10 days in the spring as far as biomass accumulation. So the earlier we can get it seeded in the fall, we take advantage of that time frame and we can get more early biomass out of that crop. That can help us with weed suppression for other species. And then allowing it to grow later in the spring, it doesn't take as much time in the spring to accumulate the same amount of biomass that it would in the fall. So early planting is good, and we've done a lot of great work as far as developing technologies to get really effective early seeding. I think pilots have gotten a lot better at evenly seeding cover crops across fields. I think we've got some really cool opportunities with some of these high boy seeders where we can get things directly in the field in a standing crop, allowing us to seed early. And it seems like we often catch those kind of early to mid-September rainfalls that can really help us in getting some of these established. I know a lot of Iowa is really, really dry this fall. So again, biological system, it's not always perfect. It's not always going to work the way that we want. We always need to have backup plans, but we have some really cool opportunities to make this work if people are interested in it. This was, again, this Nichols et al. Research where they looked at a lot of research that was out there and then did some modeling. And so to get that kind of 4,400 pounds of biomass for the 75% suppression of weeds with the cover crop, they were able to kind of model when the earliest termination date was across the Midwest to get those different levels of biomass. And so you can see in central Iowa, we're kind of looking in that mid-May to potentially early June timeframe. In some areas, it's just not going to necessarily be as feasible to get that much cover crop biomass produced, right? Minnesota, Wisconsin, North Dakota, South Dakota, it's going to be a lot harder to accumulate that much biomass. But as some of those earlier graphics showed, we can get incremental help by even getting maybe 20, 25, 30% weed suppression or water hemp suppression potentially with these cover crops, even with not a lot of biomass out there. Maybe your cover crop can only get 12 or 18 inches tall, but it can help for some time. And so this is a nice little visual that originally was based solely on herbicides, talking about layered residual herbicides. But I've sort of taken this from Bob Hartzler and I turned it around to talk about how that cover crop can act kind of like a residual herbicide in the spring. And so this first line that's sort of moving across the graph here, this cover crop degradation line, used to be just a residual herbicide line. And that's very much what a residual herbicide would do in the spring. As soon as it hits the soil, it starts to degrade. And so think of this as like the termination timing of your cereal rye or whatever your cover crop of choice is. And as soon as you terminate it, that is going to start the degradation process. It starts to die back. And that first herbicide application to terminate that cover crop may have a soil residual product and it may not. That probably depends a lot on your philosophy as a grower. It depends a lot on how much soil you can see out in that field. How even is my cover crop? Am I going to get really good weed suppression everywhere, or do I need that herbicide as a backup? And as that cover crop starts to degrade, eventually weeds are going to start coming through. And so some of the process of this is that, again, it's not going to be season-long suppression. We may get some early suppression from the cover crop, but we need to boost that weed suppression back up. And that's when we would, in most cases, come back with a post herbicide application, in which case in Iowa, especially in soybean, we're going to put in a residual herbicide so that we can continue to get some longevity of weed control as we're sort of waiting for those the canopy to fill in and help add some suppression for the weeds. And so I like to say that that cover crop can act like a residual herbicide for up to maybe 6 weeks, which depends a lot on your cover crop species, the size of the species, the spring weather that we're having, and things like that. But it can absolutely help in suppressing these weeds. And so again, back to my Pampers, right? Up to 100% weed suppression, but probably not. But they absolutely can help in that partial weed suppression and take some pressure off our herbicides. And so just a quick summary here. Water hemp is going to continue to stack herbicide resistances and become harder to kill. Thus far, there is no detriment to water hemp plants having herbicide resistances. So even if we were to remove herbicides from a system completely, it's unlikely that any of the herbicide resistances already out in the environment would disappear from a population. So all we're going to do is continue to stack herbicide resistances. It's just a matter of how long we can eke through with these products and continue to make them useful. And things like cover crops can help suppress the weeds and help get more longevity out of our herbicides. So farmers who are going to be successful at outwitting a la Survivor, Outwit, Outplay, Outlast, Waterhemp are going to be ones who are able to implement non-chemical strategies that are going to complement our herbicides. And cover crops are a really easy opportunity in soybean to make that work. And cereal rye in Iowa is by far one of our most viable non-chemical strategies to help us in this fight. So with that, I'm not sure what, I'm almost perfectly on time. This is brilliant. I just wanted to put this slide up here as I finish, and while you're thinking, I have a QR code on there that will take you to our crops page, so you can see contact information for all of my colleagues across the state and everybody on our crops team. And then that link there will do the same thing. So if you just type that in your web browser, you can access that as well. So thank you for having me today. All right. I think I'm ready for questions, maybe.
Okay. Well, I think there should be a couple more slides, right, that I need to go over?
Yes.
Yes. Okay. I got to do my job as a moderator here, one of my jobs. If you watch this webinar live and would like to earn a CCA CEU, please email Alena Whitaker, ALENAW at iastate.edu by 5 o'clock today with your name, that name you entered to watch the webinar, and your CCA number. Again, Alena Whitaker, ALENAW at iastate.edu. I think the next slide should be the voluntary demographics survey. If you watch this webinar live and are willing to fill out the voluntary demographics survey as part of USDA funded programs, it would be greatly appreciated. Only one survey response is needed for all 2024 webinars. You can go to iowalearningfarms.org/survey or scan the QR code there. And I did see one question come in that I can answer quickly. Yes, this webinar will be available within the next probably 24 to 48 hours. Alena will get it posted on the Iowa Learning Farms website or the Iowa Learning Farms webinar YouTube channel. So, okay, next slide. Sorry, Megan. Okay, next week we have conservation easements, protecting Iowa's private lands and investments in conservation. We'll have Anna Gray with Iowa Natural Heritage Foundation. And then I think there may be one last slide just to highlight again that the webinars are archived on the iowalearningfarms.org/webinars website, web address, or at our YouTube Iowa Learning Farms-webinars. Okay, so we got some questions that have come in, Megan. I guess one of the first ones is, how did water hemp originate in our corn soybean systems?
Oh, that's a good question. Water hemp is native to Iowa, and my understanding is virtually all of the Midwest.
Okay.
And it's traditionally thought of as kind of like I think a wetland weedy species. And so as we farm a lot of ground that was previously not crop ground, I think water hemp has probably been here for a long time. The question is, when did it start to become a problem? And that varies across the Midwest and Iowa. I think it was the early 90s. And I think that likely tracks very closely with our use of the ALS inhibiting herbicides, group 2 products. So Bob Hartzler might kill me, but I think probably it was often in crop fields before that. But we picked it out and selected for it by using ALS chemistry, of which it was very easy for water hemp to become resistant to. So basically almost 100% of our water hemp populations in Iowa are likely resistant to the ALS chemistries, and that happened very quickly. So it went from a population of plants in fields like, oh, there's all these pigweed species, right? Redroot pigweed, smooth pigweed, maybe water hemp out there, to we can kill all the redroot pigweed and the smooth pigweed, but now we have these plants that are surviving, which were the water hemp.
All right. Has there been documented yield impact of water hemp on corn and soybeans in Iowa, and what might the range be?
There's good research that in the Midwest, I would say, that looks at the effect of that has looked at the effect of water hemp and on corn and soybean. I think the populations that we see today, I don't know whether they affect yield. I don't know that there's been any recent research that has looked at these populations of water hemp just kind of hanging out above the soybean canopy and how much effect that might have on crop yield. There's really good research that looks at like season-long competition, and if we have very high levels of what, if you've got 20 plants per square foot or square meter in a field, right, we can look at some pretty substantial yield effects. But I think some of these fields that I see, we're absolutely seeing yield effects that are much harder to track because it varies as you look across fields, and there's not a lot of research that's been done in that. But I would say that we are really hurting ourselves from the seed bank perspective, right? Even if we are not affecting yield, we are growing that seed bank substantially every year.
Okay, great. All right. Couple people asked, they were surprised by the Italian ryegrass and that winter wheat having better control in water hemp than rye did in the Wayland study. Any thoughts on that? And I'm just going to ask, I have to laugh at this. Stefan said, what is this, Megan's prelims? No, we're all that.
No, this is, hey, Stefan, this stuff postdates any of that kind of stuff by many years, and there will be no PhD. So I was kind of surprised by that too, right? But it is further south, right? That was Missouri data, and I would say one of the issues that we have here in Iowa. First, I don't have a vendetta against Italian ryegrass or anything, but ryegrass is known to have herbicide resistance issues, right? It is weedy in other cropping systems across the US. And so I think that there's probably not been much research looking at it in Iowa or even in the upper Midwest, because we know in these other geographies it can cause problems. And I would say that both with the ryegrasses and with winter wheat, we are likely in this area to have more overwintering issues than we would in the South. Okay. So cereal rye is going to much more reliably overwinter year over year. So if we were to get one of those really cold winters where we've got like no snow cover, I think we'd be more likely to lose Italian ryegrass and wheat in Iowa. And so I think that perhaps they could numerically suppress weeds better if they were allowed to grow. And they were able to make it through the winter. But I think cereal rye is our best bet here in Iowa for several reasons.
Okay. There's a question, is water hemp edible for humans?
Yes.
Okay.
Yeah. Any of the pigweed species, I'm really going out here, and I would encourage somebody to do some independent research that, like, you can eat them, but just because you can doesn't mean you should, maybe, right? Especially with a weedy species in Iowa, who knows what may have been treated on it. And the day we decide we're going to grow water hemp for something useful is the day it probably won't grow well anymore in Iowa.
Yep. Okay, so let's get back to your study. Where you had that September planting that grew to about 18 inches. Do you remember what the rate of seeding of that cover crop was?
We actually looked at multiple seeding rates, anything from, I think, a half a bushel of rye all the way up to 4 bushels of rye. And by the time that we terminated that rye, when we dried down the biomass from our samples, there was no statistical difference in the above ground biomass in those plots. And so I think that's something that is seen in multiple studies, that when we get very close to maturity, as long as that rye has grown well, right, it can tiller and it fills in space really well. So you don't get real huge differences in above ground biomass, even across seeding rates. But that does, the higher seeding rate in the fall gives you more biomass early and gives you more ability to adapt if weather conditions result in death of plants and things like that.
Any information on how grazing of cover crops might have a positive or negative effect as we think about weed suppression?
That is a really good question that I don't know the answer to, but I hope that person can send me an email, right?
Okay.
We know that grazing, if we graze too late in the spring, we can reduce grain yield or seed yield from small grains, right? There is a point in time where you need to stop grazing with livestock in order to make sure that you're not going to affect yield. And so I would imagine that the work, if we looked at for work that looked at weed suppression, that those results would be similar, right? If you graze too late, you're going to reduce its ability to grow and suppress weeds. You won't have as much above ground biomass there.
Yep. All right. Have you looked at different seeding methods and the impact on cover crop biomass and impact on weed suppression?
I personally have not. So it seems like it's all about establishment, and I think that if we went and we looked at an airplane every year, it would vary every year how well it established. And so of course with drill seeding, you're going to get more reliable, even establishment of plants because you get better seed soil contact if you look like year over year, but you have to seed much later.
Yeah.
And so there's trade-offs, of course.
Yeah. I was just thinking that you mentioned that like 30-day wind, 30 days in the fall is like 10 days in the spring. And the time period between maybe interseeding it and drilling it might be that 30 days. Now,
Absolutely.
yeah, this year it's a challenge because we seeded a month ago and then we've gotten a quarter of an inch of rain in that last month. So we didn't get much from these 30 days this year, but that's yeah.
Thus is the life of trying to grow a crop, right?
Yeah. Okay, another one. Is water hemp a problem in CRP lands?
Typically no.
Okay.
It water hemp well, sorry, I'll back up. When I was in school, Bob Hartzler always said, like weeds, like crops. And so the weeds that do well in an individual crop are ones that are likely to follow the similar life cycle, right? So we have water hemp issues in corn and soybean in Iowa because water hemp comes up about the same time or shortly after corn grows, and it's able to produce mature seed before those crops are harvested. And so when we move into a more perennial system, we're likely to see more biennial and perennial weed issues once that system is established, right? During that initial establishment year, we're going to see all kinds of annuals and winter annuals show up in CRP. But if that is a well-established CRP, water hemp is unlikely to be a big issue in it.
Yeah. I always learn something from Bob because I hadn't, yeah, that makes sense with the weeds. Okay, researchers in Pennsylvania showed N fertilizer can increase rye biomass to improve suppression. Do you think in our soils, there might be a benefit?
Oh, that's a good question. I should ask Matt Helmers that question. I mean, I don't know because we have a lot of nitrogen cycling that happens, right? So
yeah. So we do. I will say that when we injected manure into rye at the Northeast Research Farm, especially the first few years, we really saw higher biomass production right over where we had applied the manure, so there was an increased biomass. So I think that there could be that potential to increase it, which might provide some weed suppression benefits. Then we'd need to look at is there any slight trade-off in reducing nitrate reduction if we put more fertilizer there?
Yeah, and I think the bottom line question is the additional value of weed suppression you might get worth the cost of putting on more nitrogen with the application? I would suspect it's not.
Yeah. There was Bob Hartzler is on, and he said, tell Megan to cite how Palmer didn't persist in the contaminated CRP fields.
Oh, yeah, right. So that's like the perfect example of an annual not doing well in a CRP or a perennial type environment, right? I don't even remember what year that was, 2016, I think. Right. We saw Palmer amaranth come in with
Yeah.
some native seed mixes. And it was a big problem the first year we saw a lot of it. But with mowing and with establishment of those CRPs, I've never gotten a phone call about any of those fields that we visited that Palmer was persisting there.
Okay. Another one, do you have any recommendation or insights into how effective the residual chemistries um, might be when used in a high biomass situation?
Yeah, so that's, 25 minutes is limiting, but I'm glad somebody asked this question because we know that, you know, if we go out to terminate a high biomass cover crop like rye, right? Big tall green rye in the spring, and we put a residual herbicide in there, that residual herbicide that gets in contact with the green tissue is very likely to be taken up by it. And we know from some work done on certain residual herbicides, sulfentrazone is one that Missouri did some work on, looking at how much of it was taken up and is it released back into that system, right, at some point, right? Is it shoved into a vacuole, and as that plant degrades, it becomes available again? And the answer was it didn't become available again. And so there've always been kind of rules of thumb as to when to include a residual, when to not. And I would say that on the whole, I don't think we get well enough established rye perfectly across fields to leave the residual out in most cases. But if we can do that, you can absolutely, right, you save some costs on the residual, and then that rye alone acts as the residual. But the problem is it seems like we've always got gaps and stands and spots where it's not as well established and things like that. But yeah, the green living crop absolutely going to take up the herbicide, at least as far as the work I've seen so far, probably not going to give it back to the environment.
Do you have enough info at this time on yield reductions from water hemp, shortening corn or soybean varieties, timing of cover crop seeding, rate of seeding to build an economic model to help farmers make decisions? I think I might know the answer to that, but
I'm gonna have
I'll
to
put
phone.
it.
We'll phone a friend on this one. No,
Yeah.
no, but
Yeah.
there's a lot of really talented modelers out there and talented economists, and so I would think that we've got there's great data on weed suppression from cover crops. I think the challenge is again, this biological system means we probably haven't studied it year in, year out enough over time to figure out, over 10 years, what's our average weed suppression going to be? Because the weather's always changing and how well things get established, and what works in one area maybe doesn't work in another. But it's a cool idea. It would be awesome.
There was somebody asked here, and I can't remember if we've talked about it in any of the prairie strips meetings, water hemp issues in prairie strips.
I would expect that it would be much like any other CRP.
Yeah.
The only issue I think with prairie strips would be that instead of having your CRP in one big block where you have defined borders, right, on four sides, right, your prairie strips are spread throughout the field, and so you have more of that fringe area where I know we've talked about this before, where you've got really good ground cover that's suppressing water hemp in those strips, and then you've got corn maybe growing in the field, but you end up with that kind of fringe area where the plants get more sunlight and they get a half rate of herbicide or something because it's just that kind of edge effect, right? So you get more edges, and those areas could potentially be problematic.
Yeah, especially at the edges. I guess I've not heard Tim Youngquist talk about that as much as I think most have been more concerned with thistles in the prairie strips. But
I think not in the not in the strip. It should not be an issue in the strip. It would just be in that kind of fringe, the outer couple feet of the cornfield.
Yeah, kind of that disturbed zone also. That would be an area where you're also going to get some sediment deposition as well. So it's always kind of a disturbed zone on the upstream side of those prairie strips. All right. I think, I guess you kind of talked about this, but do you think the water hemp control comes from the lack of sunlight to the ground, stabilizing soil temperatures, end tie-up, or a combination of all the above?
I think
or
it's a
just
lot of things. For water
yeah?
hemp specifically, I think the sunlight is the really big
Okay,
factor because water hemp is only going to germinate and emerge from the upper, maybe like half inch, 3/4 of an inch of
yeah,
soil. I hope Hartzler corrects me if I'm incorrect there, but very shallow emergence. And so you pile a bunch of thick rye residue on top of that, and you're reducing that light quality that those plants are getting. So they've got less area to germinate from.
okay. All right. I think that pretty much answers all of our questions. I think Megan indicated if you have additional questions that you could contact her. We'll go back to her. I would say also go to her information, sign up for her weekly newsletter. Is it weekly?
No,
Okay. All right.
monthly.
All right.
I do it once a
Monthly.
month.
Okay. Okay. I couldn't remember.
I
All
don't have
right.
that kind of
So
time.
yeah, yeah. I know when I said weekly, I was like, whoa. So thank you again, Megan, for participating. Lots of great questions and discussion. And I think we went to 45 minutes. So you will get one CCA credit if you need one. And so email Alena Whitaker, ALENAW at iastate.edu by 5 o'clock today with your name, the name you entered to watch your webinar, and your CCA number. With that, everybody have a great rest of the week.